Speed time graphs, part 2, level 1 mechanics. A speed time graph can be used to calculate distance traveled. Alright? And the way you do this is you calculate the area under a speed time graph line. Alright, here we've got a speed time graph. Okay? And you need to make sure when you're doing these things that it is a speed time graph. Make sure you read what your axes are. If this was a distance time graph and you do this on an exam, you're going to get the question wrong. Alright, so make sure you read the graph. Okay, if we put a horizontal line on here, you can see the speed is 40 meters per second and it stays constant. It's a constant speed, so there's no acceleration. But you can calculate the distance it travels at that constant speed. So from the graph, calculate how far the object traveled during the first 10 seconds. So basically we want to determine how far the object has traveled up to 10 seconds. And to do that, we find the area under the line. In this case, it's a nice rectangular shape, and as I hope you already know, area equals base times height. Okay, that for a rectangle, base times height, or you may know it as length times width. Doesn't really matter. And distance equals base times height. Okay, so in this case, we've got a base of 10 seconds. Okay, starts at 0, goes to 10. Okay, so that's a base of 10 seconds. And the height starts at 0 and goes to 40. Okay, so that's a height of 40. All you have to do then is multiply them together and you get 400 meters. Very easy. Let's do another example, this time with a slope or a gradient on the line. It's not a horizontal line. And we've got the question, what is the distance covered in the first 12 seconds of the journey? So again, we will calculate the area under the line. In this case, it's a triangular shape. And I hope you already know this, but the area of a triangle is 1/2 base times its height. Okay? So distance equals 1/2 base times height. In this case, we've got a base of 12. Starts at 0 and goes to 12. So the base is 12, and it's 12 seconds long. The height, which is this distance here, goes from 0 all the way up to here, and in this case, that's 80. Okay, so that's why I put the 80 here. So to do the calculations, it's easy. 1/2 times 12 times 80. If you put this in your calculator, instead of a half, you can put 0.5. And you multiply that out and you get 480 meters. Now, suppose we have a shape that is not a triangle or a rectangle. What distance is covered in the first 12 seconds of this journey? Well, I've colored in underneath the line, and you can see there are two shapes there. There's a triangle and a square. Okay, and what you're going to have to do is calculate the area of this triangle. Whoops. Bit crooked line, this triangle, and the area of this square. Okay, and then you add them together. So the distance is going to be 1/2 base times height of this triangle right here, plus base times height, the base and height of that rectangle. So we put in our values. For the triangle, it's got a base that goes from 0 to 4, so that's our base. And it's got a height that goes from 0 to 60. Okay, and that's what we've got here, 4 and 60. 1/2 times 4 times 60. The rectangle, we go from 4 to 10. So that is a time. It starts at 4 seconds, goes to 10. That means our time is 6 seconds. And it goes all the way across here. Alright, so that's our base. Our height goes from 0 all the way up to this line here, which is 60. So it's 6 times 60. So 1/2 times 4 times 60 is 120. 6 times 60 is 360. Now all we have to do is add that up, and we get 480 meters. Very simple. You should be able to do this on your exam. And that's how you do it.